So my name is Peter Kieseberg, and I'm with SBA Research. That's a small non-profit research institute in Vienna. And I want to talk about QR code security. Actually, what's this talk about? Well, it's about a collection of things that we thought we had, ideas we had during the last years, and all the things we saw from other people. So not everything I'm presenting is made by us. We'll mention what's not by us. And yeah, that's the rough agenda of what we are doing. But we'll come to each topic later in the talk. Okay, what was the motivation? Somewhat was a bit forced on us. At least in Vienna, QR codes are getting more and more popular. Everybody has to have a 2D barcode somewhere. It's if you're a big company, you're not legible without having a product putting some code somewhere. The interesting thing is they're not human readable, okay, obviously, but people are buying into them. So you see people actually scanning them, using them. There are a lot of, let's say, lotteries from companies using them, and these are obviously working. Then there was a talk, we heard a talk on barcode abuse by FX from Phenoelite, which you all know. I think it was DEF CON 16, where he had a lot of fun with one-dimensional barcodes, and also mentioned the possibility of extending this to two-dimensional or barcodes. Yes, and then there was the Samsung debacle the problem with Samsung phones, I own one too, with the USSDs, where you could execute things on your phone, USSD codes on your phone remotely. So a bit on the background about QR codes. What was planned when using QR codes? Actually, were invented by Denzel Wave in Japan, 1994. And they were never, ever designed for putting them somewhere out in the public and letting people scan these things. They were actually for logistics, for components, for Toyota. Why? Especially if you're crafting really complex machines, especially in the aircraft, especially for airplanes, if something fails, you have to be able to track back every component. If you have got a screw and the screw is designed to hold for 10,000 hours, it fails after 2,000 hours. You want to go back, no, when did we produce the screws? Are screws that we produce at the same time, do they have the same problems, and so on and on and on. You have to store a lot of data, and that's what's the reason for the QR code actually. To have a machine-readable code that can contain quite a large amount of data. So what is used nowadays? Actually, they're still used in logistics, but nowadays they're more a commodity thing. There have been, getting my laser, things, yeah, bags where you have the QR code with some nice link or somewhere else. Advertisement, obviously, often with some colorful elements inside to have a bit more. To add a bit more for the advertising company. And in the Netherlands, there's even a coin with an imprint, with an embossed QR code. If you scan this code, I think you're directed to the mints of the Netherlands mint factory. Well, what is a QR code? Actually, there are 40 different versions of QR code. It's a 2D code with 21 to 177 modules. This can store quite a large amount of data. And it allows for different source encodings. You can store numbers. You can store alphanumeric, a set of alphanumeric symbols, which is mostly used for links. You can store some 8-bit data, but you can even store kanjis. These are the symbols, the Chinese symbols used by the Japanese. They're fully encodable in these codes. And there are other codes, ECI encodings, so industry standard, industry-related encodings, and it's possible to have your own modes if you really like, if you want to define them. That is possible, actually. Same, we'll come later to this for mixing modes. Well, some other characteristics. They're immune to rotation, and they can cope with a fair bit of distortion. And that's needed if you want to print. Usually, as I say, it wasn't planned to print them on posters. It was planned to print them on parts, on packagings. So you have to be able to cope with distortion. They provide error correction, 4 different levels, 7%, 15, 25, 30 at least. So usually if you encode, you get a bit more error correction out of them. It's a free standard, still owned by it's owned and patented by Denso, but they have said they allowed the free use of this standard, and there are currently a fair amount of decoders available. Well, what's the structure of such a QR code? Actually, the most prominent thing is the finder pattern. The reason for finder pattern is for the scanner to identify the code, to identify rotation, amongst other. So there's other methods too, but this is the first one. Second, separators between the beneath the finder patterns. Third one is the timing pattern. These two rows here. They're always looking the same. They're here for enabling the device to fix the coordinate system it uses internally for decoding the code. It's also additional information on the version used, because they just can count the number of pixels here. And furthermore, it's used also for calculating the pixel width. Yeah, and then there are alignment patterns. If you've got bigger codes, you've got much more of them. In the first version, you've got none. And then up to 6th version, you've got 1, and then it starts getting more and more and more. They're also here for distortion, mainly for coping with distortion. Then you've got the format information here. It stores various things like a version of the QR code, the masking, I will come to this later, in use, and the error correction. And then here's the data part. Actually, it's simply stored systematically. The first bit is stored here, then it goes up, it goes down again, whoops. And so it's just some kind of zigzag line where it's stored. Afterwards, there's the error correction bits. And afterward, there are some remainder bits depending on the version of the QR code. Well, I said for masking, it's important that the distribution of the black and white modules, as these pixels are called, is first equal, and it's equally distributed about the whole code, with the exception of the finder patterns. And that's why a set of 8 masks is used. So first, if you generate QR code, you make the source encoding of the data, then you make the encoding inside the QR mask, and afterwards you XOR all 8 masks on your QR code. And then you take you select the one that had the best distribution for the code. So slight changes in the underlying information can result in a complete change in the code, in the QR code in the resulting, due to another mask being used, even though this is a systematic encoding. Okay, the first thing, that's nothing we did, that I think it's well known maybe, malicious USSD codes. USSD is unstructured supplementary service data. It's defined in GSM standard, and it's some way for getting communication between cell phone and the provider. It's a real-time connection, and you can do things like phone configuration, retrieving, showing your IMSI and such, or EMI and such things. It's also used for mobile money services, and there was a really great talk by Ravi Shankar Borgaonkar, by Ravi, on the TalcoSec day on Tuesday, where he waded a bit deeper in the details of using USSD codes for various malicious purposes, including deletion of the phone. So possible threats, for example, the actual codes, actually, I have to say, they often depend on the vendor. They're vendor specific. And especially on the Android, and USSD is treated like a number. So you can link to a USSD, and it's then executed on your phone. So there's, for example, the kill codes for cell phones, where you just make silent book changes, for example, or silent factory reset. Here's I want you to for Ravi. For the QR codes, actually you can define links in QR codes, and so you can also encode USSD codes in QR codes, surely. What do you need? You need a QR code generator, okay, that's easy. A suitable USSD code, that's easy too. Usually you can get it, or from many phones you can get them on the net. Yes, and then you need an Android user with an app that directly executes a link found in a QR code. Fortunately, today, the most prominent QR code decoding devices or decoding programs, they first show you the code before they execute a link that's inside. But in former times, it was different. There were a lot of them. You just scanned. You just looked with the camera at the QR code, scanned it, and it followed the link. And then, yeah, you have to have a dialer, like in former times, the standard dialer for Android, that dials automatically. And then you can do a lot of funny things using QR codes. Just printing out malicious QR codes, put them somewhere on the wall, and wait for people to scan. And then you have fun, or not, or they don't. Okay, that's one thing. The other thing that's quite nice is phishing with QR codes. So what's the idea behind all these advertisements? You have an advertisement, there's a QR code, let's say log in with your Amazon account and click on this code, log in with your Amazon account and get the next, don't know, 10% off your next shipping costs or whatever. What happens? The user scans the code, enters its credentials and logs into the site. The question is QR code legit? I mean, users have learned to look at, or I believe users have a bit learned, at least, to look at hyperlinks if they're valid or not. But for QR codes, I mean, they're not human readable. You can scan them. You scan them, you follow them. You maybe don't look. You maybe have an address that looks a bit similar. Especially if you've got a small device, you just follow it and you're phished. Okay, that's maybe not really interesting for, okay, you can phish people using hyperlinks, that's true. Well, here we've got Neo. Neo is a bit sad because he's thinking about maybe the other pill was the right thing to take. And to cheer him up, we've got a nice donation running. So if you can donate money in order to give a kitten to Neo. What's behind this? That's actually a standard that's currently been standardized in Austria. Actually, this QR code resembles this. This is a payment order. We have them since, I say, decades. You can go to a bank, take one, fill it out, and do your payment. The interesting thing is this was ported to QR codes now. Here's the, it was by Stutzer. Stutzer is actually a kind of association containing all Austrian banks, and their target is finding ways for finding new ways for deploying payments or for doing payments. They're existing since 1991, and they did things like online banking in Austria and so on and on and on, and made the standards for this, the national standards. So, and every bank in Austria is part of this, so they all will accept this. And they are currently building, I wasn't able to try it really with a bank account, because there's currently one bank that claims to already have it in their online system, and that's not my bank. And since they all say they will start it in second part of 2013, I say I'm from Austria, so I say it won't be before 2014, 15, but okay, they will do it. That's the standard actually. So if we have a look at this, there's a service ID that's just a fixed string value of BCD saying this is a payment. The version, it's just a version of the document. We're now in the versions 1.11, and there's small changes, slight changes to the first version. Then there's the encoding, if you've got UTF or easy encoding of the following data. And function is again direct link to service ID, it's always SCT. And what you have inside is the BIC, the BIC, the recipient account holder, and the IBAN. These are three are mandatory. All these are mandatory. These three are the interesting parts. We want to enter our BIC and our IBAN. Yes, you're rather limited. You're not allowed to do more than 999,999,999 euros with one transfer. I personally think this is really annoying. You have to fill out two then if you want to do the billion. But well, that's not mandatory actually. You can put up a sticker without an amount, without a cash amount in it, and afterwards the reader, by the specification, should ask the person what to enter here, the customer what to enter here. It's also only euro allowed. They have a currency symbol, but still there's only euro. And you can add a purpose, reference, text, and a message to be displayed to the user actually. Well, so if we go back, here we have the BCD for the system. This is the BIC. This is the IBAN. This is the issuer. This is the amount of money want. This is some kind of reference text, internal reference text. And this is our message that's displayed to the customer. Well, so far so good, so obvious. Actually, I've said, this is going to be standardized maybe in the whole European Union, because currently this is provided to European Payment Council for standardization. So maybe this standard will be the upcoming standard in whole Europe for doing these kind of transfers. So okay, the question now was, can I fake these? Can these only be issued by banks, or can I do this? Okay. Let's have a look at their website. Well, there you have. I'm really sorry, it's only working in the German version, though. So if you click on the English version, you just get a blank screen. Here you have some kind of tool where you can fill out all your data, and then click on Get Code, and you get this nice code. Well, and you scan it, and it should be the same as I told you before. Well, okay, but the question is, I can do this here. Can I do it myself? Is there something, maybe additional encodings or some cryptographic ideas added? Actually, they also provide you with a tool for checking. So we thought of maybe just generating our own QR code with our own QR code checker. So we just have some small Python-like script. I'm not a real coder, so please forgive me my source code here. And actually, it's nothing special. It's just we add all the data and put it in a string and encode it with a QR code library. You have it's QR code 2 from the Python library, actually. Well, we can run this. Not really tricky. Sorry, needs to sorry, it's new, sorry. Okay, then we have defined we've got the resulting code. Well, okay, looks nice. Let's check. I think it should be the same that we have in yeah, it's the same content. So as in the original code. The question is this legit? Now let's use our tool. Where have I got my cursor? It needs this closed though. God, it's horrible with the remote here. And decode this. We've got the information, all the fields are valid. with some additional reminder option, and it can be decoded. So there's no, as we've seen, there's no additional crypto or some other security mechanisms. Right. Added to this element. So and actually what I can do, I can just write my own, actually. Why not? You can spend, so if you want to spend money to me, yeah, it's now just for your audience. This is not my real account number, so if you want to spend me the money, just ask me for my real one, okay? Thank you. So, okay, other things where to look at. We should look around. Every self-respecting company nowadays puts a QR code somewhere. Look at train. There's the CAT, the city airport train, that's connecting Vienna to Vienna airport. It's a rather expensive fun. I mean, it rides for 15 minutes. It costs 10 euro, but you can do a check-in at the train station. So, I mean, the normal train costs about euro 10. So, we always have online tickets containing QR codes. They're really fancy with a really big QR code there. And then additionally, your name and your number. And we thought, okay, we bought some of them. We bought one and went to the airport. The funny thing was when this guy came for control and checking the tickets, it took him half a second. He took the ticket, looked at it, gave it back to us. So we didn't even check any QR code. We looked at what the contents of this QR code. There's some pattern in the number. Actually, it's the number that's printed on the beneath. There's a pattern in the number about direction and day. But as short as they're looking on these tickets, I don't think they do some really tricky task, except he's some kind of cyborg scanning my QR code. But actually, I think it's just there for fun and just there for looking cool and secure and whatever. Ah, well. What about production lines? Now we said the origin of the QR code was production lines, or actually was logistics, but for parts. So actually, they should be used in production lines. The problem is there's no real standard for really looking, saying, yes, the standard got failure. Everybody more or less, or they are proprietary systems. We're currently trying to get our hands on one. Actually, there's a big Austrian waffle machine developer, and who's doing these waffle machines for ice cream waffles and so on. And they've got a quite big SCADA system actually, and I hope we get our hands on the test system and try to have some fun there with inducing maybe machine codes or something. Still, this is completely proprietary and wouldn't be able to transform this to somebody else. Well, then we go back to our advertisement poster. We thought about it would be cool just phishing with a pencil. I mean, you've got all these nice posters there. What happens if I just walk up to one, change colors of some of the white fields black, and go away? Can I do something interesting with this? Can I do maybe some phishing? Can I do some other changes? Maybe changing the amount of money. Yeah. What I said for the Stutzer, what I forgot to say for the Stutzer thing is, I'm expecting for the money transfer, I expect this will be a huge thing in 1 or 2 years when in Austria when all these fundraising companies will start putting it on their advertisements. I'm sorry, I've never encountered one to date, so I had to make up Neo, but it would be fun having this in a real advertisement. Okay, here phishing with the pencil. Well, first, search for useful parts. What are the parts we want to change? There's the mask. The mask is encoded. The mask we use is encoded in the QR code. Actually, well, it's stored in informant information. There are 8 different masks, and they're used, as I say, to generate this 50-50 distribution in the end, therefore getting it scanned better. Changing the mask obviously changes large parts of data and error correction parts. It's encoded separately with a really strong PCH code. And actually, we didn't really care about this much. Maybe it's useful as basis for further attacks, for just changing the mask for then launching additional attacks. The other thing is character encoding. I lied to you when I said the data is simply stored there in the data section. Actually, it's contained in blocks. It's blocked. You can usually have what you see of one data block. There's first a description, how this data has to be interpreted. Is it numerical data? Is it alphanumerical data? Is it kanji? Then there's a character count indicator, and then the data falls. So you cannot take both, maybe. Maybe the character encoding. Well, maybe interesting. Maybe interesting for having coding checks and for changing, not solely changing the character encoding, but in addition to other changes, it could be really cool, and it could be really cool when doing mixed modes. The other would be the character count indicator. Well, this length of block is solely detected by the character count indicator. There's no terminating symbols for data blocks or else. So you could change this and do some kind of overflow, underflow, buffer overflow, QR code overflow, underflow attacks. Still, we want to do, this is the one thing we really want to do with the production lines, though, where we really have machine code there, because this could really prove interesting. If we've got in mixed mode a string encoding a command to the machine, afterwards a data part containing the actual things to the actual data that's sent to the machine. Could be really cool. But still, we don't have hands on a production line. They're rather expensive, I've heard. So what constitutes the largest part of the QR code? Actually, the data part and the error correction, and the bits, the remainder bits. They make up the largest part, and the data is encoded using a Reed-Solomon code. So what's a Reed-Solomon code? Reed-Solomon codes are a subfamily of PCH codes. They're designed to detect and correct random changes, random errors, simple errors. And they're optimal and systematic codes. What does systematic mean? Systematic means that the error correction bits are simply appended at the end. So the first part is your original message, and then you've got the error correction part. That's why you have a data section in the QR code, and afterwards you've got the section with the error correction bits. They're optimal, means for the given characteristics, or for needed characteristics, you don't find a code that's better. And they are here with 4 different levels of error correction. Actually, you can design Reed-Solomon codes with completely different characteristics too. That's nothing special. So for PCH codes, PCH code Bose, Chaudhuri, Hockenheim codes. And okay, these are simply codes working with polynomial multiplication or division, you can choose. And polynomial multiplication and division is rather fast on fields with characteristic 2. So they're commonly used. They're, for example, used in the form of Reed-Solomon codes, for example, for CD encoding, where you have the compact disc, you know, these things before MP3s took over. These small things that you put somewhere and they played music or whatever. So actually the calculation is rather for getting the challenge codes. You have the general polynomial, that's a primitive polynomial about the base field. You have a source encoded data, okay, that we need, and you get the challenge encoded data by simply multiplying. So it's really fast. Well, now say, okay, if we change, okay, I think a designer died when I designed this slide. Okay, this, we have a little difficulty, we only want to change one color. So we are not, if we change a simple change of a random bit, a random module in our data section, or in the error correction section, it doesn't matter actually, they're equal with respect to this, then a lot of other pixels change. And some will turn from black to white and others from white to black. So we can't just simply overwrite them with the data we want. But we have the error correction, and the error correction is helping us. Why? Well, let's say we have a message in the original QR code with a message Q1, and we want to reach a message QX. We don't really have to change models in order to directly hit QX. We only have to reach the vicinity where the error correction is taking over. So we just have to reach a QR code, not a QR code that's in here, in the QX, but some slightly wrong code that's only a bit wrong and not too wrong, so it can't be corrected with the error correction, and that's possible actually. So we don't need a direct hit here. So for the attack outline, that's the first one. It's our, the attacker scans the QR code on the street and retrieves the message inside. Well, what you can do now is simply generate a set of messages looking alike with phishing URLs. Yeah? Maybe we'll want to have messages that look really, really close in the ASCII representation. So if the QR code decoder is showing you the link, you maybe just click it because it looks familiar. Then we construct the change matrix. Well, it's just an extended XOR. You put in a 1 if there's a change from white to black, -1 if it's a change from black to white, and a 0 if we've got no change. It's just a matrix. For each message, we construct our matrix of containing the changes. What we do then, we remove all the impossible solutions. If the number of models that we have to change from black to white, is bigger than the error correction, what happens then? Well, we have no chance of hitting this circle. We will always lie outside. This field here is a bit big. It's just for illustration purpose. These are all the QR codes that are not uniquely decodable to one real solution, or that we don't care about. Well, so we can throw them away. For the remaining, we just sort them by least effort from white to black. So in this white to black in ascending order, and then recolor or take the first and recolor our original QR code and register the web page, for example. Okay. So to have it here, we have here the original QR code. That's yahoo.at. We, for example, choose. Well, it's close to similar on a small screen. Let's put it that way. We generate the difference here. That's only the difference containing the black pixels. The pixels we have to color black in this. So these are the pixels we have to change here to black, not in order to generate this, but to generate a QR code that's decoded by the error correction towards this QR code. Yeah, and then we simply encode then we simply change our QR code here. Okay, that was one idea of doing this. The second is we could do it the other way around. Why not just simply change random modules in our QR code and look what happens? Possible too is just scan the QR code, retrieve the message M0. Yeah, and then we have this matrix of all the modules, how they're called. Let's change, let's say, a bit more than the error correction you have to change. Run per random. And then decode it again and look what's the web page, for example. Do this 100 times, for example. 100 times yielded good results, actually. And then you choose one, for example. Yeah, for example, we have here our QR code. Then that's yahoo.com, yeah, yahoo.com. Here, there's a list of, let's say, an excerpt of 100 different changes. So we simply changed pixels here in the error correction in the data part. Actually, we didn't change it in this part, obviously. So, and decode it again. So it gets simply a set of completely random, no, not random, simply randomly changed addresses. Okay, it was the wrong button. You maybe want to select, here's an excerpt of some that were selected. The number in the brackets is always how many modules had to be changed. So this was low error correction, 5 modules, 6 modules. In the end, you choose one and look at what modules you have to change in the end. You can do this way. Okay, I have to change code here, for example. Okay, and there's another approach. We're going to put the outline. You remember when we had the money thing, the money deployment thing from Stutza? Some parts were free for us to configure, so if we wanted to change it, and some parts we had to really change, some fix. For example, I want the IBAN to be my IBAN and not some IBAN that of you, for example, yeah, because I want to get the money, obviously. So these are fixed. Actually, there are other fixed, for example, from the structure, like the line breaks or the whole fixed things in the start. What you could do then, actually, that's related to the work here, to his work on QR codes. We'll come to back later. Is that you can utilize one thing from one characteristic of QR codes. That's they are isomorphic with respect to XORs, for example. So XOR is an isomorphism on this. If you've got here two messages, two different code blocks, and this is the BCH encoding of these blocks, then it doesn't matter if you first XOR two data blocks and take the BCH encoding, or if you just have the BCH encoded data blocks and XOR them afterwards. So XOR is Reed-Solomon code is stable with respect to XORing. You could use this, for example, in course of Gauss-Jordan elimination. That's what you do is you find the basis for each. You find the base vector for directly changing elements in your field. This works because this whole Reed-Solomon code is some kind of vector space, and you find the basis for the vector space, and then you look what's changed by the vector space. Or if you change one elemental vector. Actually, this is based on QR codes work. QR codes is a nice homepage, so if you want, you would really recommend have you look here. His target is designer QR codes. QR codes that resemble where the black and white modules resemble a face or a picture or something else. And it's really detailed, it's really cool. It's the other way around than we need. We need to get the code that we need in order to achieve a certain pattern, and he does it a bit the other way around. But still, it's really interesting. Downsides of this approach, and that's why we don't really have implemented it. It's not possible to change single modules, and you're not able to change all modules because in order to control modules, you would have to change, or you would have to have complete control over the data inside the first part. And obviously, we don't want this. We want our IBAN in there. Furthermore, the masking thwarts back recalculation of this thing. Small changes in the code could result in completely different masking, for example. So in the end, it comes down to brute forcing again, and the other two approaches were also brute forcing approaches, which are simply faster, in my opinion. So we should stick with the old approaches. Well, now we come to the central question. Who cares, actually? Yeah, well, it's a valid question to ask. And what we do here is or what we are currently doing, is some kind of field study. In the acceptance of QR code and user awareness concerning security. I copied this from the funding proposal, so please forgive me the cloudy language. What we want to do, or what we're doing currently, is publish QR codes with link to a study on public places. We've selected 5 cities: Athens, Helsinki, Paris, Tokyo, Vienna. Why those 5 and not others? Simply because we have the supporting guys there. Support guys there. So in Athens, we've already deployed it. 2 in Helsinki, Paris. In Paris, we already got some first results. In Vienna, we are currently deploying. We're always a bit late. And in Tokyo, we have huge ethical issues, and we don't know if we can do this kind of field study in Tokyo. I'll show you afterwards how they're looking like. Plain stickers, stickers with some small description and QR codes with a pic. The Japanese Ethical Commission told us that all 3 of them would mean tricking people into things, into actions they maybe don't want. Actually, I see the point, I have to admit. All the other, just in Europe, it's not that You're not so concerned with ethical issues, maybe. And we now have some proposed that we maybe use a cover leaf. So we have the QR code on a sheet of paper and another sheet of paper in front of it with it writing something like, do you want to participate in a survey? We're currently discussing if this is ethical enough, if this passes through the ethical tests. If not, we'll just forget it, because, yeah. So we've got a plain sticker. We've got the sticker with the question, participating in our security awareness survey. And the second one and the third one, there are several pictures with nice cats, whatever, dogs, whatever. What's inside the code? So every QR code is unique, obviously. Contains unique ID, and additionally the city, deployment type, and link to a survey. Why? Okay, the link to the survey is obvious because we want people to follow this. But why the city deployment type? We have the people deploying the QR codes. We don't always want to phone them if they mix up the sheets. They should just be able to scan it and look where it should belong, where it belongs. Deployment, yeah, we go for several profiles of people. So we have bus stops, that's nice. Toilets, we've seen, actually that's just a funny thing, but if you go in a pub to a toilet, you always see these nice writings on the wall. And recently we just found people putting stickers with QR codes there. So we thought maybe there is a business case in sticking pictures of QR codes to toilets. I don't know. If I get rich with it, I'll tell you, okay? And then around the campus, and then some random places, ATMs, vending machines, it should mean, not machined, parking machines and such things. Well, what happens if you click on a field study? We're automatically logging that you scanned it. Okay. We log the QR code and scan time and retrieve some information using Google Analytics, country, city, browser, if it's deployed correctly. Yes, we have the OS, but we throw it away. With the service provider, we throw it away. And there's the possibility to identify new visitors. So maybe some persons will be that happy to have this survey, they want to click it, they want to do it 3 times. I'm sorry, that will just distort everything. And all personal data is removed again. Then there's a redirection of the user to a survey. I show a disclaimer, who we are, what we want to do, and that we guarantee anonymity. And show a survey of 7 questions, and measure time to complete the survey. And we always measure how many people clicked or scanned the QR code and then filled out the survey. So that's the survey questions. They are rather straightforward. It takes 3 to 4 minutes currently to complete the survey. Why did you scan? It's all multiple choice. Why did you scan the QR code? Did you have any doubts or malicious expectations before scanning this code? Did you check the web address before visiting the link? Have you been knowingly, of course, the victim of a phishing attack? And how often do you scan QR codes? And then there's some age, gender thing that's needed for afterwards for having really nice statistics, a lot of nice bar plots, so we can, yeah, that's like the mumbo jumbo around a bit. But it's nice. So the results, no, we have no results. As it's told, it's currently done. We're currently in deployment phase. It currently takes 3 to 4 minutes to complete the survey. We have a survey and we have a high acceptance. So more than 50% of the people scanning QR code actually complete the survey. That's really nice, in my opinion. We expect about 2% or so. I don't know. And currently I can't say, but Kitty seems to be winning. That's the QR code that's scanned the most often, actually. Okay. Countermeasures against phishing. And oops, I have to get a bit faster. Always show the links. What would you if you program what should you do? You should always show the links. What I've thought of would be interesting is some kind of additional blacklisting. That doesn't mean I really do blacklisting of real sites, but maybe do some kind of pattern matchings on links. So if you just have Google with 1 O, so that you just additionally warn the customer. Look at the ad for detecting tampering. If there's some sticker covering the QR code with null QR code, maybe this is not legit. And what's nice is you could also, and that's the technical countermeasure, you could also check the mask. All the coloring things I showed you, they change the distribution of black and white models, obviously. So you could detect it by just looking at the distribution. And if it's not 50% or really close to 50-50, then there was tampering involved. For USSDs, there have been proposed many other countermeasures also. And for the payment orders, I think it would be cool to have some additional verification procedure in it. Still, 5 more minutes. I want to show a bit more fun. You can have QR codes. And what's the main thing is, like I said before, you use a technology designed for storing really large amounts of data for storing www.google.com. Now, I don't have nothing against Google here, yeah, but it's a short link. It's this version 4, lower L barcode. Low means it's lower, it's only 7% error correction, but still can store 640 bits. In alphanumeric mode, that's 114 characters. That's still 100 more characters than we used here, actually. In numerical mode, it's even more. So we have space. Why not use it? I see. Actually, there have been some approaches. The first one, they hid information in QR code, but they didn't hide it in the data of the QR code, but in the picture. So they did this. They hid it in the least significant bit of each color channel of the QR code. So the QR code got a bit light gray, but the data was stored with classic picture steganography. Two-bit steganography was quite close to the same. It was rather similar. Maybe the most interesting is this one. They are encoding the data in a QR code and then hiding the QR code in another picture. So if you're got good decoder, you can simply scan the QR code, but for a normal person, it looks like a picture, a legend picture. That's really interesting, but something different than we want to do. Okay, we have to store just a link. I mean, what we could do, for example, that's trivial. After a link, we can store a hashtag and store our information. Well, that's quite obvious. If you scan this code, you just see everything. Next thing is, what about mixed modes? QR codes, or let's say the standard of QR codes, allows many things that many encoders are not able to do. I've never found an encoder on the web, or at least no free encoder or encoding library that's giving you the whole thing that QR codes actually should be able to do. And one of the things that's mostly left out is the possibility of having more than one data chunk. And you can have different modes in these data chunks. So for example, I could have a data chunk alphanumeric containing this one, and then just some numeric parts. Okay, that's still, it's a bit better, but still queer. What about the error correction? First, we used error correction to get to change the underlying information. Why not use the bits of the error corrections, bits that are corrected anyway, to store information? For example, in a bigger QR code, I can induce, 100 errors, 100 erroneous bits, and they're still getting the code to the original data. So I have got 100 bits for hiding information, for example. So what would be the idea? You have, you use, for example, high encoding. You have then to use high error correction. Encode some kind of cover data in the QR code. That's the thing that's displayed if you scan a QR code. And encode your real data in the error correction. Not in the error correction bits, but in switched error correction. I'll show you afterwards. So what you do when you want to read it, you scan the code. You create a QR code with the same characteristics and the same message as you read it from the cover data, and then calculate the change matrix I've shown you before, and then you know it. Then you have got the bit representation, more or less. So what can you do at the start? What you could do is you could just encode your data at the start of the QR code. That's a problem because of distribution again. You will have run into maybe large black fields at the start of your QR code, and this gives you problems with decoding. Also remember, the mask is here for getting the decoding done. So you can scatter it through the code. What we do is simply encode a switch from black to white, and erroneous switch from black to white. So a white symbol instead of the correct black one is 0, and 1 for the other way around. And then calculate the change matrix, and read the binary representation. So there's pros and cons. The pros is it's not detected by common readers because they simply do the error correction part. That's what the error correction is designed for. Links and looks and works is like always. It's rather easy to decode. You don't have to do some kind of XOR. The problem is not much capacity. So version 4 code with high error correction gives you 240 bits. Well, it's not even enough. So I guess in version 5 it will be enough to store a key for an encryption, for example, encryption key. And that's much more, doesn't utilize the error correction. So if any of these 240 bits is changed, it won't be corrected. Because the error correction is working on the cover message, not on your hidden message. Yeah, and it's detectable. And since all the masking is getting, the distribution of the mask is maybe getting lost. So, let's have another look at the terminator. Okay, there's Arnold Schwarzenegger, of course, but there's also another terminator. Each QR codes possess one. After last data block, there's a terminator block containing 4 zeros or less. So if the message is long enough to fill out the whole QR code, there's no terminator. And if there's 1 to 4 bit left, it's encoded with 0. And after the terminator block, the data segment is simply padded with these 2 sequences alternately. Well, hide data after the terminator in the padding. The pros and cons. The pros are manifold. The reader software should end decoding after terminator. That's according to the spec. So every decoder obeying the spec won't look at the padding pattern. The links looks and works like always. It's even easier to encode and decode. You have to find the terminator, especially for decoding. You just search your QR code until you find terminator and get it over with. Read out the data. Next thing is your hidden data is still protected by the error correction. So if you've got error faults there, for example, because of dirt, it's still got the same protection because it's still even the padding is sent through the error correction mechanisms through the Reed-Solomon code. And last but not least, the distribution of black and white models is not destroyed because the masking is applied afterwards. Maybe a different mask will be chosen. That can happen, but the distribution is always there. Yeah. On the other hand, you'd only have to do pattern matching after the terminator, but still. Okay, what's the conclusion? Yeah. Actually, all the attacks are all trivial. What they're doing, they want to trick you to scan some QR code and do bad things with you. But there are new attack vectors. And for example, there are attacks against new kind of people. People who go around the street and, well, seeing a nice QR code, scanning it. And you see those people. They link the paper ads to the digital world and target unsuspecting users, unsuspecting customers. And they're getting more and more interesting as more and more delicate applications are done that are based in QR codes. And I think it's only start. This is now for the European Commission for standardization, and maybe we'll get the European standard. Then I think there can be many nice things be done with this. Yeah, QR codes can be used for many things. What would be nice to do in future work, or we haven't said, maybe some looking a bit more on special user-defined encoding, continuous QR codes. It's possible not only to have data stored in one QR code, you can have up to 16 QR codes, for example, that are linked together. So you scan them in an arbitrary direction. You don't have to do it in line. And then the QR codes can together form information. Usually I've never seen a freeware encoder being capable of designing such codes. I don't think there is a decoder for this currently. But I mean, there are decoders for industry, but not for commodity. Same as with the buffer under and overflows. And hopefully in the next month there will be working payment apps, and we're really fun having a look at them. And for the steganography part, I think I would like to do some practical implementation of the terminator thing and try to run through steganographical detection mechanisms. yes, last but not least, some thanks. Sebastian, over there. Katerina is currently in Japan doing fighting against ethics. And Ioannis from Greece, who was able to get this distributed in Paris. And all the friends in Helsinki, Athens, Helsinki, Paris, Tokyo, and Vienna, who are helping us with the field study. Thank you.
Thank you, Peter. Are there some questions?
So first of all, thank you for the talk, and I really appreciated the research you did on this magic marker attack, I would call it, this making up of black pixels. But one thing which I think is missing in this idea is that it's totally impractical to. So let's say I have like the Red Cross is asking for donations on like 1,000 flyers somewhere. Nobody would use like a mask and use a magic marker and like draw 1,000 pixels on each of these things. He would just like order 1,000 stickers for $10 or something and stick them on him. So
you have me here. Good, that's true. Actually, that's also why I didn't dig too deep into this really systematic recalculation of these payment codes, since it doesn't make sense applying too many of them. Actually, the idea was more or less like some kind of, like guerrilla gardening is now popular in Vienna. So you have some maybe people who just want to trick other people. So you got this app. Scan the QR code, tells you what 5 pixels to change, and you do it simply. And you do it not systematically in order to gain money, but in order just to, get to know new people, for example. But you're correct for the payment part. That's why we left it then.
More questions? So then I have a question.
Oh.
What about implementing encryption? Do you know if there are some steps towards this?
Actually, there are crypto QR, secure QR. Still, I had a look at it once. Actually, the first thing is the QR codes they're used nowadays here in this advertising thing. They are really plain QR. According to QR standard, there's some kind of secure QR. Still, they don't do internal validation. So it's not about like using hash values for internal validating that no bits got changed, but it's more like if you link to external password. If you, for example, want to exchange passwords, if you link to external password stores that you have got some kind of encryption between, or what the main part is, it's just a standard for efficiently encoding encrypted data. But it's not a sanity check. They don't implement sanity checks if the data itself was tampered. That's not in the scope of the secure QRs.
Probably you know that the Deutsche Bahn uses QR codes in the tickets. I would have asked you if you know if they are using some layer of security.
I really have to say I really don't know. I was buying my tickets when I go to Germany via the Austrian railway guys, and they don't have. They simply have a strict-looking guy in the train who's looking if your ticket looks legit.
Okay, more questions. So then we have the lunch. Thank you. Another time, Peter.
Thank you.